Leaving Cert Higher Level 2019, Paper 1, Question 3. So part A starts off by saying factorize fully 3xy minus 9x plus 4y minus 12. So we've got a total of 4 terms here. So when you're trying to factorize something, you're asking yourself, well, the first thing you should ask yourself is there anything I can take out of each term? So if we look at the first two terms here, we can take 3x. We could, both those terms there are divisible by 3x. So if I take 3x, or if I divide 3x into the first term, I'm left with y. Dividing it into the second term, I'm going to be left with 3. Plus and then 3 will divide in, or 4 will divide into both of these terms. So let's take out 4. So if I take 4 out of the first term, I'm left with y. Out of the second term, I'm left with minus 3. So then we've got, what we've now done is we've turned what was 4 terms into now 2 terms. That term plus that term. So again, we're going to ask ourselves here, what's common to each term? And the thing that's common to each term is y minus 3. So because y minus 3 is common to each term, then we're going to take it out. So if I divide y minus 3 into this term, I'm left with 3x. And if I divide it into the second term, I'm left with plus 4. And that's it now, fully factorized. And that's part A done. So then moving on to part B here, it says g of x is 3x ln x minus 9x plus 4 ln x minus 12. And it says using your answer to part A or otherwise, solve g of x equal to 0. Well, okay, so if g of x is equal to 0, then all of this is equal to 0. Now, with this, they're in a way giving us a hint as to how to do the question, even though it can be done other ways as well. So, first of all, I'm going to replace g of x with what it actually is, which is those 4 terms. But if we notice, these 4 terms are sort of in the same form those 4 terms are in. It's just that ln of x has now replaced y. So when we factorize that, we got that. So when we factorize this, it'll look exactly like that, except y will be replaced with ln x. So we can actually use this answer to help us solve this. So yeah, because y is replaced with ln of x in this situation, we can replace y there with ln x. So when we factorize the left-hand side of this equation, we're going to have this ln x. I'm just going to use this up here, but replace y with ln x. So ln x minus 3 times then 3x plus 4 is equal to 0. So then I've got 2 things multiplied by each other equaling 0. So the first thing is going to equal 0. Or the second thing is going to equal 0. So then ln x is going to equal, bring the minus 3 across and make it plus 3. So ln x equals 3. Now, so ln means log to the base e. So we're going to have a log of x to the base e is equal to 3. Now, to get x here, we need to write this from log form, which is the way it is at the moment, into index form. So this equation at the moment is written in this form. Log of 100 to the base 10 equals 2. That's log form. But I want to write it in index form, which is this. 100 equals 10 squared. So it's like my 100 in this case is the x, my 10 in this case is the e, and my 2 in this case is the 3. So we're going to replace 100 with x, replace 10 with the e, and replace the 2 with the 3. So x, when we write this equation from log form into index form, it becomes x equals e cubed. So that's one solution for x. And the other one is going to be found from this equation. So 3x is equal to minus 4. X is equal to minus 4 over 3. So there are my two solutions. This one here, and this one here. It's always advisable to make it obvious where your answers lie. And that's part B completed. Now moving on to part C here, it says evaluate g dash of e correct to 2 decimal places. Now I've done a solution for this previously. So g of x, we factorized it earlier and we got 3x plus 4 by ln x minus 3. So that, to differentiate that, well, to get g dash of e, we're going to first of all get g dash of x. Then we're going to replace x with e. Now to get g dash of x, you're going to be, because this is a product, you're going to use product rule. So g dash of x here is going to be u dv dx plus v du dx. So it's a case of, my u here is 3x plus 4 and my v is ln x minus 3. So I've written down those two things first, and then so it's about getting dv dx and du dx. So I'm getting du dx first. So if u is equal to 3x plus 4, du dx then is going to be 3, differentiating that. If v is equal to ln x minus 3, differentiating that, dv dx becomes 1 over x. So then I've got everything I need now to sub into the product rule. So g dash of x is going to become then u, which is 3x plus 4, by dv dx, which is 1 over x, plus then v, which is ln x minus 3, multiplied by du dx, and du dx here is 3. So then it's a case of just multiplying it out. So 3x by 1 over x is 3, 4 by 1 over x is 4 over x, ln x times 3 is 3 ln x, minus 3 by 3 is minus 9. So that's what the derivative is, that's what g dash of x is, but they're looking for g dash of e, so you're going to have to sub in e then into your derivative. So g dash of e then becomes 3 plus 4 over e plus 3 ln e minus 9. I'm just replacing all my x's there with e. So then that becomes 3 plus 4 over e, but ln of e itself is 1, so 3 by 1 is 3, minus 9. So they're looking at, they want it as a decimal, so you just put that into the calculator and get it as a decimal, and to 2 decimal places it's minus 1.53. And that's question 3 completed.